In part 1 of the question, we are supposed to do a differentiation. The expression that we are supposed to differentiate is e to the power of sine inverse x, square root of 1 minus x squared. And 1 mark is allocated to this, especially when it is just a pretty basic differentiation where we are going to be making use of product rule. I guess it is not that bad. I'm going to hold this term constant, e to the power of sine inverse x. I'm going to differentiate this. So treating this as if it is a 1 minus x squared to the power of half, it is going to be half, then 1 minus x squared to the power of half minus 1, which is going to be minus half. Chain rule. Then we are going to differentiate 1 minus x squared, which will give us a minus 2x. Then plus this term, I'm going to differentiate now. It will be e to the power of sine inverse x. Differentiating sine inverse x is 1 over square root of 1 minus x squared. Then I'm copying this term, so it will be square root of 1 minus x squared. So this and this can be cancelled. It is a plus. I'm going to write it in front. So we will have a e to the power of sine inverse x. Then minus 2, they can be cancelled. So it will be minusing x e to the power of sine inverse x over square root of 1 minus x squared. Okay, a little bit tedious for a 1 mark question, but it is not difficult. Part 2 is the part of this question that I find rather challenging. For part 2, we are supposed to try to do an integration for x e to the power of sine inverse x over square root of 1 minus x squared. And the question gave us a hint. We are supposed to make use of the previous result and at the same time integration by parts to attempt to integrate this. It actually took me a while to find the 2 parts to integrate. So in the end, after doing a bit of trial and error, trying to find the 2 different parts to be used for integration by parts, then I realized that if I were to be letting u be equal to x, and if I were to let dv dx be equal to the other portion, which is this, I'm going to rewrite this as 1 over square root of 1 minus x squared, then e to the power of sine inverse x. Again, I think this is a no-brainer. This is just du dx, which is going to be equal to 1. As for this, we're going to apply a bit of fx f prime x, okay, where this is fx, f prime x is this. So integrating this should be giving us e to the power of sine inverse x. Like what I was trying to say just now, I find it a bit challenging because there are different ways that I can be combining these 3 terms together in order for me to have 2 terms for integration by parts. So it took me a while. Okay, I don't want you to assume that it was very straightforward, that we know exactly x to be u, exactly this to be dv dx. It is not. Okay, it is through a bit of trial and error. Let me continue. So with this, then this is going to be equal to uv. So it will be x e to the power of sine inverse x minus integration of v du dx, which is going to be 1. So it is actually integration of this e to the power of sine inverse x dx. And this is, again, something that we are not able to integrate. And since the question says we are supposed to be making use of the previous result, let's just take a look how the previous result can lead me to resolving this. Okay, this is the only portion that is on the right hand side that we are still not able to carry out our integration. So if I were to differentiate this, I'm going to be getting this. This will also imply that if I were to be integrating this, I'm going to be getting this expression here. So let me write it down here. What I'm trying to say is that if I were to be integrating this, which is going to be e to the power of sine inverse x minus x e to the power of sine inverse x over square root of 1 minus x squared, this should be giving me an e to the power of sine inverse x square root of 1 minus x squared plus c. Okay, and in here, we actually see, okay, or rather, we do need to be able to observe 2 integrals. One is this integration of e to the power of sine inverse x, which is actually the same as this. The other one is going to be the integration of this, which is actually the same as this. Okay, so what I'm going to try do is I am going to try to break this expression into two integrals and then bring this over to the right hand side so that I can have a representation for integration of e to the power of sine inverse x, which means this will be x e to the power of sine inverse x minus this, okay, integration of this. Bring this over to the right hand side with the integration notation. Let's not forget about it. It is going to be e to the power of sine inverse x square root of 1 minus x squared minus, bring it over, it will become plus, let's not forget about the integration notation, so it will be x e to the power of sine inverse x over square root of 1 minus x squared. Okay, and now if I can just look at this here together with this as one full statement, maybe just let me write down a version of this here. Okay, so it is actually integration of x e to the power of sine inverse x over square root of 1 minus x squared. Okay, this is equal to this. And now we have a repeated integral. So I'm going to shift all the same integrals over to the left-hand side. Okay, so it will be this minus, shifting over it become plus. So we will have 2 times of this. Okay, so shifting this over to join the integral on the left-hand side, you'll be giving us 2 times of the integration of x e to the power of sine inverse x over square root of 1 minus x squared dx. And on the right-hand side, we are going to be left with an x e to the power of sine inverse x minus e to the power of sine inverse x square root of 1 minus x squared. We can definitely write a plus c here, but for this kind of process that we have been encountering before in other probably simpler questions, I mean, it is okay, to just ignore the plus c first, because I will still need to divide the 2 across to the other side before I get my final answer. I just want to make sure that in my final answer, I will still honor that plus c. So let me write down my final answer, which means the integration of this x e to the power of sine inverse x over square root of 1 minus x squared. This is going to be dividing 2 across to the other side. It will be half. Then x e to the power of sine inverse x minus e to the power of sine inverse x square root of 1 minus x squared, then plus c.